NENOMATICA, where mathematics meets YouTube excellence. Welcome to our math tutorial on factoring polynomials. Today, we'll learn how to factor expressions by finding the greatest common factor and using factoring by grouping techniques. Let's start with our first example. We need to factor the expression a to the power of 3b to the power of 8 minus 7a to the power of 10b to the power of 4 plus 2a to the power of 5b to the power of 2. Before we continue, I want you to take a moment to think about what common factor we might be able to pull out from this expression. To factor this expression, we first need to identify the greatest common factor, or GCF, of all terms. Let's look at the powers of a in each term. We have a to the power of 3, a to the power of 10, and a to the power of 5. The smallest exponent is 3, so our GCF will include a to the power of 3. Similarly for b, we have b to the power of 8, b to the power of 4, and b to the power of 2. The smallest exponent is 2, so our GCF will include b to the power of 2. Therefore, the greatest common factor is a to the power of 3b to the power of 2. Now, let's factor out this common factor from our expression. We can rewrite our expression as a to the power of 3b to the power of 2 times the quantity, b to the power of 6 minus 7a to the power of 7b to the power of 2 plus 2a to the power of 2. Let's verify this by distributing the common factor back in. A to the power of 3b to the power of 2 times b to the power of 6 gives us a to the power of 3b to the power of 8. A to the power of 3b to the power of 2 times negative 7a to the power of 7b to the power of 2 gives us negative 7a to the power of 10b to the power of 4. A to the power of 3b to the power of 2 times 2a to the power of 2 gives us 2a to the power of 5b to the power of 2. So we have successfully factored our expression as a to the power of 3b to the power of 2 times the quantity, b to the power of 6 minus 7a to the power of 7b to the power of 2 plus 2a to the power of 2. Now, let's move on to our second example. We need to factor the expression 6x to the power of 7 plus 3x to the power of 4 minus 9x to the power of 3. Before we continue, can you think about what the greatest common factor might be for this expression? For this expression, we need to identify the greatest common factor of all three terms. First, let's look at the coefficients, 6, 3, and minus 9. The greatest common factor of these numbers is 3. Next, for the variable x, we have x to the power of 7, x to the power of 4, and x to the power of 3. The smallest exponent is 3, so our GCF will include x to the power of 3. Therefore, the greatest common factor is 3x to the power of 3. Now, let's factor out 3x to the power of 3 from our expression. We get 3x to the power of 3 times the quantity, 2x to the power of 4 plus x minus 3. Let's verify by distributing. 3x to the power of 3 times 2x to the power of 4 equals 6x to the power of 7. 3x to the power of 3 times x equals 3x to the power of 4. 3x to the power of 3 times negative 3 equals negative 9x to the power of 3. So our factored expression is 3x to the power of 3 times the quantity, 2x to the power of 4 plus x minus 3. Let's reinforce our understanding with another example, which happens to be the same as our first example, but shown again to reinforce the concept. We'll factor the expression a to the power of 3b to the power of 8 minus 7a to the power of 10b to the power of 4 plus 2a to the power of 5b to the power of 2. As we saw earlier, the factored form is a to the power of 3b to the power of 2 times the quantity, b to the power of 6 minus 7a to the power of 7b to the power of 2 plus 2a to the power of 2. Let's summarize what we've learned about factoring polynomials. First, we identify the greatest common factor by finding the smallest exponent of each variable and the greatest common divisor of all coefficients. Second, we factor out this GCF from each term in the expression. Finally, we verify our answer by distributing the GCF back to make sure we get the original expression. Practice these skills with more examples to become proficient at factoring. For further study, you can explore factoring by grouping, factoring quadratic expressions, and the difference of squares or cubes. Thank you for watching this tutorial on factoring polynomials. Keep practicing these techniques, and you'll soon become confident in factoring even more complex expressions. We want to factor the expression 18a to the fourth power b squared c to the fourth power plus 12a squared b to the fourth power c to the fourth power plus 24a squared b to the fourth power c to the fourth power. Let's start by factoring out the greatest common monomial. To do this, we need to identify the common factors in all terms. We need to find the greatest common factor in all three terms. Looking carefully, we can see that all terms share 6a squared b squared c to the fourth power. So we can factor out 6a squared b squared c to the fourth power from the entire expression. This gives us 6a squared b squared c to the fourth power times the quantity 3a squared plus 2b squared plus 4b squared. Next, we'll combine like terms inside the parentheses. Inside the parentheses, we can combine the terms with b squared. We have 2b squared plus 4b squared, which equals 6b squared. So now our expression becomes 6a squared b squared c to the fourth power times the quantity 3a squared plus 6b squared. Now we can factor out the common factor 3 from inside the parentheses. Looking at the terms inside the parentheses, we see that both 3a squared and 6b squared have a common factor of 3. So we can factor out 3 from the parentheses, which gives us 3 times a squared plus 2b squared. When we pull out this factor of 3, it multiplies with our previous common factor. 6a squared b squared c to the fourth power times 3 gives us 18a squared b squared c to the fourth power. So our final factorization is 18a squared b squared c to the fourth power times the quantity a squared plus 2b squared. Now, let's look at another example. We want to factor the expression for a squared b times a plus b plus 2a b squared times a plus b. In this expression, we can see that both terms have a common factor of a plus b. Since both terms contain a plus b, we can factor it out. This gives us a plus b times the quantity for a squared b plus 2ab squared. Now, we need to factor the expression inside the second set of parentheses. Looking at 4a squared b plus 2ab squared, we can factor out 2ab, giving us 2ab times the quantity 2a plus b. Therefore, our complete factorization is 2ab times a plus b times 2a plus b. We need to factor the expression 9x squared times the quantity 2x plus 7 minus 12x times the quantity 2x plus 7. Looking at this expression, we can see that both terms have a common factor of the quantity 2x plus 7. Let's highlight this common factor. When we have a common factor, we can use the distributive property to factor it out. This is based on the distributive property, which tells us that a times b plus a times c equals a times the quantity b plus c. So we can factor out the common term 2x plus 7, and we get the expression 2x plus 7 times the quantity 9x squared minus 12x. Now, we can further factor the expression inside the parentheses. 9x squared minus 12x has a common factor of 3x. So, factoring out 3x, we get 3x times the quantity 3x minus 4. Therefore, our final answer is the quantity 2x plus 7 times the quantity 3x times the quantity 3x minus 4, which simplifies to 3x times the quantity 2x plus 7 times the quantity 3x minus 4. Let's move on to our second example. Here we have 2x times the quantity x squared plus 1 to the power of 3 minus 16 times the quantity x squared plus 1 to the power of 5. For this example, we need to recognize that we have terms with the same base, x squared plus 1, but with different exponents. We can use the property that says a to the power m times a to the power n equals a to the power m plus n. And similarly, for the second term, we can write the quantity x squared plus 1 to the power of 5 as the quantity x squared plus 1 to the power of 3 times the quantity x squared plus 1 squared. Now we can factor out the common term, the quantity x squared plus 1 to the power of 3 from both terms. So our expression becomes the quantity x squared plus 1 to the power of 3 times the quantity 2x minus 16 times the quantity x squared plus 1 squared, which we can write as 2 times the quantity x squared plus 1 to the power of 3 times the expression x minus 8 times the quantity x squared plus 1 squared. Let's simplify our result a bit more for better understanding. Using algebra, we can write our final answer as 2 times the quantity x squared plus 1 to the power of 3 times the bracket x minus 8 times the quantity x squared plus 1 squared. Let's start with our example. We need to factor the expression x squared times the quantity 2 minus 6x plus 4x times the quantity 4 minus 12x. Let's first take a closer look at the second term. In the expression 4x times the quantity 4 minus 12x, we can rewrite this in a way that reveals a common binomial with the first term. We'll use the constant factor extraction rule. Notice that 4 minus 12x can be rewritten as 2 times the quantity 2 minus 6x. This gives us 4x times 2, which is 8x, times the quantity 2 minus 6x. Let's rewrite our original expression with this substitution. Step 1. Rewrite the second term to expose the common binomial. Our expression now becomes x squared times the quantity 2 minus 6x, plus 8x times the quantity 2 minus 6x. Now we can see a common factor in both terms, the binomial 2 minus 6x. Using the common binomial factor rule, we can factor this out. Step 2. Factor out the common binomial 2 minus 6x. When we do this, we get the quantity x squared plus 8x times the binomial 2 minus 6x. We can further simplify x squared plus 8x as x times the quantity x plus 8. Let's rearrange our factors to get our final form. So the factorized form of our original expression is x times the quantity 2 minus 6x times the quantity x plus 8. We can also write this as x times the quantity 1 minus 3x times the quantity x plus 8 by factoring out a 2 from the middle term. Let's verify our factorization by expanding the factored form back to the original expression. Here's our problem. If x squared plus 5x minus 3 equals 0, find the value of the expression x squared plus 3x plus 2 times x squared plus 7x plus 12. Before we start solving, let's understand our approach. We have a constraint that x squared plus 5x minus 3 equals 0. We can rearrange this to get x squared plus 5x equals 3. This will be our key constraint that we'll use throughout the solution. Let's start with the first step. We'll rewrite each quadratic factor in terms of x squared plus 5x. For the first factor, x squared plus 3x plus 2, we'll substitute x squared as x squared plus 5x minus 5x, which equals 3 minus 5x. So, x squared plus 3x plus 2 becomes 3 minus 5x plus 3x plus 2, which simplifies to 5 minus 2x. Similarly, for the second factor, x squared plus 7x plus 12, we substitute x squared equals 3 minus 5x. This gives us 3 minus 5x plus 7x plus 12, which simplifies to 15 plus 2x. Now let's move to step 2. We need to multiply our simplified factors. We'll multiply 5 minus 2x and 15 plus 2x using the distributive property. When we multiply these expressions, we get 5 times 15, which is 75, plus 5 times 2x, which is 10x, minus 2x times 15, which is negative 30x, minus 2x times 2x, which is negative 4x squared. Combining like terms, we get 75 minus 20x minus 4x squared. For our final step, we need to substitute the value of x squared back into our expression. Remember, from our original constraint, we know that x squared equals 3 minus 5x. So in our expression 75 minus 20x minus 4x squared, we substitute 4x squared with 4 times 3 minus 5x. This gives us 75 minus 20x minus 12 plus 20x. The x terms cancel out, leaving us with 75 minus 12, which equals 63. Therefore, the value of the given expression is 63. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.